Okay, start today. We will go through the last large topic of this class, which is about the route survey. This topic will tell you how to lay out the curve, how to design the routes for the transportation system. The survey will include the design of the horizontal curves and also the vertical curves. Here would be the contents of the all the subtopics covered in this chapter about the route surveying. We will go through the just a moment. Let me try to go to the presentation mode. So we will first go through the calculations about the curves, including how to find out the locations of the stations along the horizontal curves, and also the methods for the curve at different with different elevations, which will be the super elevation and the vertical curve layout. And after we finish the introduction about the curve calculation, we'll go through the definitions about the cross sections and how to use the cross sections to calculate the earthwork or the volumes for the constructions of the roads in the transportation system. So those would be the major contents will be covered in this chapter. For the lecture today, we will start with the horizontal curve, and we will go through some fundamental definitions about the laying out in the horizontal curve and how to calculate the length of the arc and also the radius and the length of the chord with respect to the horizontal curves. I will go through the definitions one by one. First of all, I'll give a brief overview about the necessary for us to do the route survey in transportation system. So you might know that for the transportation system, the road consists of a lot of lines, and all the vehicles is moving on this road. And for some road, there will be a straight line, which means that it will be easy for you to identify the lanes and the directions based on the fundamental surveying technologies that we learned in the previous lectures. But for the regarding to the road with certain with different directions, for the two straight roads with different directions, we either need to apply some intersections or we need to using some curve to connect these two roads with different directions smoothly, and that will require us to do the route surveying. And this one will not only apply to the highways, the local roads, but also applies to the railways, the transit lines, the canals, and also if we want to go to check the other areas, there could be laying out of the pipelines, the transmission lines, and so on. But to make it simple, in this lecture, we will focus on the highway curve alignment. And regarding to the highway curve alignment, it's highly related to the geometries of the horizontal and the vertical curves. The horizontal curves will try to connect two lines at the same horizontal plane smoothly, and while for the vertical curve, we are trying to using to construct the surface of the road to connect the two segments with different slopes. And there will be more details to be introduced about how to do the curve layout for the horizontal and vertical lines. And we also need to find out a way to get the terrain information. We need to know the elevations at different locations. We also need to know where the curve should start and where should be end. And regarding to the construction of the road in transport system, usually we will need to do, if the road is not flat, there are some difference in elevations. We need to conduct some earthwork to remove some earth from if it's too high, and to fill the deep with certain soils. And that will be conducted as the earthwork. We need to calculate how much effort we need to do to complete this earthwork. And after you do all this calculation, the rest things will be about assigning the job for those companies to get the earthwork to move to extract the earth from some areas and then move to the areas which will need some actual soils. So that will be the earthwork distribution process. We will not cover all of them, but in this chapter we will focus on the geometries of the horizontal and vertical curves, and also the calculations of the earthwork volumes. So for the highway alignment, there will be two important components. The first one is the horizontal curve alignment. We want to use the curve to connect two straight lines, or we want to use multiple curves to connect multiple segments with different directions. And usually, in order to make the connection smooth, we have to make sure that the curve is tangent to the straight line. With that, you will not observe any sharp changes of the directions for the when you are driving on the road. While for the other component, the vertical alignment, we will usually use the arc of the parabolas policy to connect the two roads with different slopes smoothly. And this is also the way to guarantee that the road is smooth enough for you to pass the regions with different elevations. So here we will have some typical examples about the one typical example is about how to lay out in a curve. You can see that there will be some important component we need we need to define before we go to laying out the curve. First of all, let me try to use my pen to do it. Usually for laying out in a curve, horizontal curve, we are considering connecting two straight lines. Say that you have two straight lines, A to B and C to D. They are along different directions, and you want to find out in the curve to connect both lines. And this curve should be tangent to both straight lines. At the point B, the curve should be tangent to the line A to B. At the point C, the curve should be tangent to the line C to D. And here you will have several important concepts. So the first one, which is also the point B, is called the PC. That represents the point of curve. It will represent the start point of the curve. And at point C, where is the end of the curve, which is called the PT. That's represent point of tangent. That will be the end of the curve. And another point you have to consider for the laying out of the horizontal curve is V, which is called the which is the point here. That will be the intersection of the extension for the two lines, A to B and D to C. V is the intersection of these two lines, and that's the abbreviation of the vertex. Or in our field experiment, we defined as the point of interest. So those would be the three critical points we have to consider to laying out in the curve. And of course, if we have the curve, then you will have the a radius. Say that the radius of the curve is r. And also we need to calculate the length of the arc. And we also need to specify how many stations we need to place along the arc, and even also continuously along the straight line for all the curves and the straight lines you're laying out on the freeway, on the road. So that's the three important points we need to think about to laying out the curve. And I'll give you more introductions about how these points will be applied to calculate the length of the arc, to calculate the values of the radius about the curve. Before we go to the detailed calculation, I would like to give you another definition about the curve, or another variables to measure the curve, which is called the degree of the curve. It shows the curvature of the curve that you're going to apply to connect two lines. So the degree of curve can be defined based on two variables. One is called the degree of the curve with the arc. The other one is called the degree of the curve with the chord. So let's start with the first definition, the arc definition. So in the definition about the degree of the curve, we can assume that we're going to select the curve, the length of the arc with the value of 100 meters. So we say that the LA as a length of the curve or the arc, and the value is selected as 100 meters. And in this figure, R is the radius of the curve, and the dA is defined as the degree of the curve with the arc definition. And then we can define the degree of the curve. So that one is defined based on the equation dA divided by LA equal to 360 degree divided by 2 pi r. So dA is actually represented with the angle, the angle of this arc, and it's for the definition of the degree of the curve, we will consider the standard length of 100 meters. So with that, you can get the a more standard definition. dA divided by 100 meters equals to 360 degree divided by 2 pi r, and r is the radius of the curve. So that's the definition about the degree of the curve with the arc. We also have another definition, which is based on the chord. So that could be shown in this figure. The chord will represent the straight line from 2 points, from between any 2 points in the curve, say that the point A and B, then the chord will represent the straight line from A to B. And in this definition, the degree of the curve with the chord, which will be DC, will be the angle with the chord length of 100 meters. So LC equal to 100 meters. We say that LC is the length of the chord. And the DC is the degree of the curve with the chord definition. So what we get is like in this situation, we can find out the relationship between the degree of the curve and the radius and the chord length. So say that you choose the middle point. You choose the middle point in the along the line A to B. Say that the point is C. Then the triangle AOC would be in the right triangle, and this is actually the property from the circle. And with that, you will also be able to find out the angle of AOC is just half of the degree of the curve with the chord definition. So with that, you can get the sine half DC will be half of AB divided by the radius of the curve. And this one can, as we say that we want to define the degree of the curve with the standard chord length of 100 meters. So AB is 100. This will give you the value as 50 meters divided by R. So that's the definition for you to get the degree of the curve with the chord definition. So that's the two definitions. One is through the arc length. The other one is through the chord length. And with the definitions of the degree of the curve, we can then go to check the more details about the geometries to lay out in the horizontal curve. And actually, before I start that, I want to give you more review about the properties of the circle and the angles with respect to the circle, especially about the angles with respect to the arc and the chord. So here, let's consider an arc. Let's consider an arc from A to B, and the radius is R. C is the center of the circle or the center of the arc. And if we know that the angle of AOB is delta, then for any point along the circle, C or C prime, if we connect them together from A to B, with that you have the angle ACB, the angle AC prime B, and you can even find out the other point C double prime, and get the angle AC double prime B. They all equal to the same value. That's half delta, which would be the angle of the arc for the for A to B. So this is the properties of the circle. And also, if you try to find out the vertex or the point of the interest for the straight line, from D to A and E to B, then assume that it's intersected at the point D. Then you can also find out the angle DAB is also half delta, and the angle DBA is also half delta. So that would be these two angles. So that's the property of the circle, which could be very beneficial for us to do the analysis of the horizontal curve to lay out the horizontal curve for connecting two straight lines. And here would be some summaries about the equations. Say that if an inscribed angle is inscribed angle in the circle is usually measured by 1/2 of the its intercepted arc, and the inscribed angle has the same or equal intercept arcs, which will also be the same. So this indicates that the angle of ACB equal to the angle of AC prime B, and it can go to some extreme case. Say that if we have a circle here, let's draw it here, and you have the arc A to B and the arc C to D, say that if you have the condition AB, the length of the arc from A to B is the same from the length of the arc C to D, then for any angle inscribed angle, say that is E and E prime, you will observe the same condition, like the AEB will equal to the angle of AE prime, not AE prime, CE prime D. So this also applies for the for those arcs with the same length. And the other things, like the for the angle formed by the tangent and the chord, it's usually measured by 1/2 of the intercepted arc. So that's the equation that we get previously. The angle of DAB will also be half of the delta. The angle of DBA is also half of delta. And the last one for the two tangent distance to a circular chord will also be the same. So this indicates that for the straight line A to D and D to B, their distance will be the same. So AD equal to BD. So these are all the features of the curve and their tangent lines. You should get some information from the geometry. So I'm not going through the details about how to derive them. You can try to review your previous lectures to get an understanding about how these relationships are estimated. And we're going to borrow this relationship to further do the calculations about the curves. So the first thing we're going to do is, like in the especially when you are working on the route survey, you are usually only provided with the several information, with the straight line informations. For example, you can be provided with the angle of the curve, say that is RI. You can be provided with the angle of the radius of R. You are provided with two straight lines, and I want in the design, I want you to do in the curve a horizontal curve to connect two straight lines to these two straight lines by using the interior angle of I and the radius of R. How are you going to lay out the curve? Where can you find out the start point, the end point, where is the intercept, the intersection of these two lines, what's the chord length, what's the arc length, and so on. So just based on these two information, I and R, we want to find out the value of the length of A to V, which would be the in this figure, that would be the length of this extension from A to the intersection of the two straight lines, and also the length of D to V, that will be the offset from the intersection to the curve. And the other one, D to F, which would be the offset from the curve, the maximum offset from the curve to the chord from A to B, and also the length of the chord A to B. So that will be the information we want to calculate based on the value of I and R. So now I'm going to show you how we can find out the value of these lines and curves. So first, let's go to check how to calculate the length of A to V. So for the length of the A to V, we need to consider the triangle we need to consider the triangle AOV. So as the line A to V is tangent to the curve. So we can conclude that O to A, the line from the center of the curve to the tangent point A is perpendicular to the line A to V. So this gives us the information that the triangle AOV is in a right triangle. So this is a 90 degree. So OAV, the angle OAV is 90 degree. And then we can use the properties of the triangle to get the value of AV. So if we go to check the tangent, the tangent of the angle AOV, that will be the ratio of AV and O to A. AV is the value we want to calculate, and O to A is the radius of the curve. So that is given as R. And we can also know that this angle, the angle AOV, is just a half of the angle of the curve. So that won't give you the information. The tangent half I will be AV divided by R. And obviously, you can quickly get the value of AV equal to R times tangent half I. So that's the first one for the calculation of AV. And well, obviously, we can get the value of AV as with the function of R and I. And for the second one, we want to find out the value from the distance from D to V. So in this figure, you can find that actually D to V equal to O to V minus the value of O to D. O to D is also the radius of the curve. So we have OV minus R as the value of D to V. And then we can still recall the right triangle AOV to find out the value of O to V. If we go to check this triangle, you can find that O to V will, or the sine of the angle, not sine, sorry. The cosine of the angle AOV will be O to A divided by O to V. And we know that A to V, the angle AOV is a half I, O to A is R. So this will give you the value of O to V as R divided by cosine half I. So you can put this conclusion in this equation. With that, you get the value of D to V as R times 1 divided by cosine half I minus 1. As the cosine value is always between 0 and 1, so the 1 divided by cosine I is always higher than 1. So you will always get the positive value of D to V. So that's the way for you to get the value of the distance from D to V. And there will be two other variables. I will go through them quickly, and then we will go to check one example to see how we're going to use them. So the third one we want to check is the distance of the A to B. which will be the length of the chord. And we know that the point F, in this case, the point F would be the center point of the line A to B. So we can get A to B will be twice of A to F. And if we draw a line, start from the center of the curve to the center line of the chord, then this line is always perpendicular to the chord. So that's the also the property of the it's also the property of the circle. So AB is always perpendicular to the line O to F. So with that, we can start with the triangle AOF, which is also in the right triangle. And if we go to check A to F, you can find that the value of AF, will be the length of O to A times sine the angle of AOF. And OA is the radius of the curve, that is R, and AOF would be half I. And this will give you the length of AB as twice of R times sine half I. And so that's the value of A to B. And the last one we want to calculate is the length of D to F. So which would be the offset from the curve to the chord. This one is relatively straightforward. You can have multiple ways to work on the to find out the distance. One way is using the triangle. As using the triangle ADF, as this one, as the line O to F is perpendicular to the line A to B, so the triangle ADF is also in the right triangle, and you can then calculate the length of DF as AF times tangent the angle of DAF. For the angle DAF is actually half of this angle, the angle of VAB, which is a half I, and then DAF will be just a quarter of I. And we also calculate the value of AF, but that is R times sine half I. So we put them together times tangent a quarter of I. That one will give you the expression of the distance from D to F. Of course, you have another way to do it. The second method would be using the line O to D. So for D to F, it actually equals to O to D minus O to F. And O to D is R. For O to F actually equals to R times cosine half I. So that is R times cosine the angle of AOF. And we know that the angle AOF is half I. So we just try to simplify this one. So this is another expression for you to find out the value of the distance of D to F. So that's the first one that the first part about the calculation. And then let me go to see give you another definition about the length of the curve, how we're going to calculate the length of the curve. Assuming that you have a curve, which is you have several points A, B, C, D, and you know the degree of the curve, which is provided as D, and you also know the total, the angle of the curve, that is capital I. So with that, you will have several methods to find out the length of the curve, which would be the length of the arc from A to D. So in the first method, you are given with R and I, and also you are provided with the value of D. You can actually calculate the value of D based on R and I. So with that, the length of the curve from A to D, length of the arc from A to D would be I divided by 360 degree times 2 pi r. So that's the equation going to use to calculate the curve from A to D. And for the second method, if we are provided with the I and the degree of the curve based on the arc definition, then you can get A to D, the length from A to D, as 100 meters, times I divided by D to A. So that's the second method. For the third method, if we are provided with given with I and the degree of the curve based on Carl definition, you can find out the approximate value of the curve, the length of the curve from A to D as 100 times I divided by DC. This, as I say, that this is just an approximate value. It should be smaller than, usually it will be smaller than the true value that you measured from the definition of the arc, and based on the radius and the angle, the angle of the arc. So that's another way, another thing we need to pay attention about the calculation of the length of the curve. And with that, I will go to one example. Assuming that you have an arc with an angle of 60 degrees 30 minutes, and the length of the line from D to E is 125.45 feet, and we want to calculate the value of R, dA, and C. So this one will require us to use the equations that we derived previously. So for the solution, I will go through some of them, and I will let you also practice by yourself. So for the solution, E, which will be the line D to V, we can recall the equation that we derived previously. That's R times cosine, 1 divided cosine half I minus 1. And in this case, we know the value of E, also the value of dV, that is 125.45. And we also know the value of the I, that is 60 degrees 30 minutes. So we get R equal to 125.45 divided by 1 divided by cosine 60 degrees 30 minutes divided by 2 minus 1. And this will give you, I'll just skip the calculation. It will give you the value about the radius as 759.86 feet. So that's the first one, how we're going to calculate the R based on the value of D to V. And then we need to calculate the degree of the curve based on the arc definition. This one is also straightforward. We can get the value from its definition. dA divided by 100 equals to 360 degree divided by 2 pi r, and give you dA equal to 100 times 360 degree divided by 2 pi times 759.86. So that is 7.4 degree, which would be 7 degree, 12 minutes. And the last one is C. C, that will be the length of A to B. We also have the definition, the equations to calculate the value. That is 2 times R times sine half I. So we get the value of 2 times 759.86 times sine. The I is 60 degree, 30 minutes divided by 2. So it gives you the result as 801.87. So that's the way for you to calculate all these three variables. And now we have 5 minutes left. I would like you to work by yourself about what's the length, what's the value of A to D. Can you give me an way about how to calculate the value from A to D? This is just a little bit of extension about the all the equations I provided previously. Do you have any ideas about it?
Can I give an idea? Yep. All right. So I was thinking, since from A to F is half of C, and we know that DAM or DAF, sorry, is a quarter of I, then we can use sine or cosine.
Yes. The that's one way to do it. Okay. So well, there will be actually multiple ways to get the result. So I'll go through the one that as what you just explained. It's actually a good method. The first method, just method 1. Consider the triangle of DAM is in a right triangle, and we know the distance of AF, which is just a half of AB, and we also know the angle. The angle of DAM is a quarter of I, so we can get the distance of A to D as AF divided by cosine quarter I. So that's one method. I can also bring you another method, which will be simpler. So in the second method, method 2, I just put it here. You can consider, for now, you can just consider this arc, A to D, and this intersection, this angle of the arc. So the angle of arc for the arc A to D is half I, and you know the radius of R, and you know this angle. So what do you do? That you just simply apply this equation. Just simply apply the equation. But here you need to change this one, change I to half I, which means that in this sinusoidal function, that would be a quarter I, right? So what you get is like for A to D, from A to D, that will equal to 2 times r times sine a quarter I. So this is the with that you can get a similar value with respect to with the first method. And this is the way for you to get the calculate the radius of the curve, calculate the length of the chord, and also some other offset that you are interested to do. You have to include for laying out in the horizontal curve. I guess I only have 2 minutes left. I will save that time for any questions you have. If you have any questions, just let me know. You can leave the message in the meeting chat or just raise your hand. Do you have any questions about the lecture today? Okay. Okay. I will go to check one. Well, there is one question about the homework 7. It's not related to this one. Well, I can give you an extension about the homework 7 to Wednesday. I guess that will be December 1st. But there's a hard deadline for the last homework because our final exam is scheduled on December 11th. So I want to provide with you about the solutions of the last homework assignment as early as possible so that I can prepare for the exam. So if you agree with that, I can give you an extension about it. Okay. Okay. If there's, I will send you the update on Avenue to Learn so that the whole class will know. If you don't have any questions, I guess that will be all about the lecture today. And in the next lecture, we will continue this topic about give you the more detailed information about how to lay out in the curve with all the informations, all the definitions we specified in this lecture. Okay, that's good. Thank you very much for your time, and I will see you tomorrow.